This video is going to show the machining of this hockey puck for the pedestal for the Black & Decker 8-inch vintage bench grinder, pedestal grinder. And I'm going to machine this out on a lathe to work with this 2-inch carriage bolt. This is a 1/2-inch threaded shaft. It's approximately 2 inches long, and I'm going to machine it in such a way that I can pull this carriage bolt up into the bottom of the hockey puck. So it'll be something like that when I'm done, times 3, because there's 3 pads on the bottom of the pedestal, so I have to make 3 of these. So I thought I'd show you the process I'm going to go through to do that. I'm going to start by drilling a center hole, and I'm going to do it in 3 steps. I probably could do it in 1, but I'm going to start with a 1/4 inch drill, then a 3/8, then I'm going to go up to the 1/2, and that will be for the threaded portion of the carriage bolt to allow it to go through. So that will be a through hole all the way through, and after that I will come back with a boring bar, and I will have to cut some relief for this squared section of the carriage bolt here, as well as countersink for the oval shaped top. So we're going to go ahead and get started here with chucking up the puck, this hockey puck, into the little 3-jaw chuck, mounting the drills, and we're going to get started. You will note that I took all my jewelry off. I do not wear watches or rings when I'm working around a lathe, or long sleeve shirts for that matter. It's a very dangerous condition to have jewelry or sleeves on when you're working with a lathe, or any rotating equipment for that matter, such as a drill press. So let's go ahead and get started. So I've got the puck chucked up in the little 3-jaw chuck, checked for clearance to make sure it's not going to contact anything all the way around. I didn't over tighten this, just snugged it up. It's not going to go anywhere, and I don't want to deform the puck either. And I have a 1/4 inch drill mounted in the tailstock. So we'll go ahead and get started. I'm just going to take my time here. There's no sense rushing, even though it's soft material. So we have the 1/2-inch through hole drilled for the threaded portion, the shank of the carriage bolt. Now I'm going to have to change the setup, and I'm going to use this little boring bar to create the countersink for the squared section here, as well as for the oval part of the head. And that'll be 2 different setups because the dimensions are different. I've set up 2 different calipers, as you can see here, that are the approximate dimensions. The first here is of the square section. You can see it's approximately 600 thousandths of an inch. I brought it in just a little bit because I want a little friction when that square section gets drawn in. I want it to resist turning, so I went just actually under 600 thousandths, just a bit there. You can see on the dial, 600 thousandths. And it just so happens it's about 600 thousandths deep. So what I'm going to do is I'm going to set this carriage stop to 600 thousandths depth. Now I'm going to bring this boring bar over just to touch the face of the puck. Then I'm going to zero this out, back this up 600 thousandths of an inch. That'll give me that depth I'm looking for, which is there. And in terms of the width of the hole itself, I'm just going to use the ears of the caliper here and eyeball it. And as I get closer and closer to that dimension, I'll check it a couple times. And that's not super critical, but I'd rather be a little under than over. And so I'll use a carriage stop for the depth, I'll use the caliper ears for the width, and I'll just start using the boring bar to open that up. So I have the gap here between the carriage and the stop set to 600 thousandths on the carriage stop. So I've got that set up. What I'm going to do now is do a couple of test cuts just to see how deep I can go. I'm going to take my time with this, even though this is a hard rubber. I'm not going to force the issue. And I'll just start making passes with the carriage, bringing it in like this while moving the boring bar out each subsequent pass to gradually open that hole up larger till I get to approximately that 600 thousandths dimension. I won't show the whole process because that could take a few minutes. It's a little bit like watching grass grow. So I'll show you the first few passes so you get a feel for what's going on, and then I'll bring you back when I'm finished. I'll go a little bit deeper. There we go. Well, we have the 600 thousandths deep and diameter hole cut for the relieved for this, or countersunk for the square section of the carriage bowl. Now we're going to move on to changing the setup just a little bit to accommodate countersink for this convex head shape here. I want that to be a little bit negative, that is to be inset just a little bit. So I measured this, and from where my thumb is, plus will be 250 thousandths of an inch. So I'm going to reset my carriage stop to 1/4 of an inch or 250 thousandths to allow the cutting tool to come in approximately 1/4 of an inch. And then I will check the width of the hole using this caliper, which I've already have set up here. Again, it's just a little bit sloppy, which is the way I want it. I want a nice comfortable fit in. And I will do that periodically. I'll just check it with the caliper ears as we're cutting away. We're going to start now on the larger of the two holes, 1/4 inch deep. I think it's a little over an inch wide. That is going to be used for the relief for the carriage bowl head. So we just finished cutting the 1/4 inch deep by a little over an inch wide countersink for the carriage bolt head. It fit like that. You can see how comfortably it fits. Actually, it'll go like this in use, and I'll tap that in with a hammer or a mallet, draw it in all the way, and then we can go ahead and mount it on the pedestal base. Well, there's the hockey puck IE pad insulator we just made over on the lathe. In order to mount this, it's real simple. Drop it through, washer, 1/2 inch nut, and then just snug it down. Again, I want the head of the bolt, carriage bolt, to be countersunk just a bit because I do not want that bearing on the floor. And there it is. There's the top view, and there's the bottom. Now all I have to do is make 2 more, and then I can see about getting this tube welded to the base here, and probably the pad on the opposite side, the platform for the grinder itself. I'll probably weld that up too. I'm more concerned about this one right now, but that's the gist of what we're going to do. So now I'm going to go make 2 more. Here you see the 3 hockey puck isolator pads are finished and mounted on the pedestal base. A little note on machining of the second 2. I didn't use the 1/4 inch and 3/8 drills to pre-drill the hole, the 1/2 inch hole, for the stem of the carriage bolt. Since the first one machined so easy, I just went right to 1/2 inch drill on the second 2, and it drilled just fine. So I saved myself a step. Here's what it looks on the back. I did not use a washer between the top of the puck and the bottom of the stand itself. It's not necessary, and I wanted a full contact surface to bear the weight of the grinder. You can also see here, I think that this is a little bit negative, the bolt head, which is what I wanted, because I didn't want this the head of the bolt to bear on the floor. I'm not intending to use lock washers here. It's not necessary, number 1, and I think what I'll probably do instead, just to prevent these nuts from backing off due to vibration, is maybe just a little dab of Loctite and call it good. I think that'll be fine also. So now that we've got the isolator pads mounted, what I'm going to do is remove them, and now I have to figure out how I'm going to permanently affix the column into the base here. I talked earlier about welding it in. I got to give that a little thought. It's really designed just to use these 3 pinch bolts on that relatively thin tubing of the column, which doesn't satisfy me. So I've got to think this through a little bit. That's why also I have the welding table out here, is I'm preparing to move on now to welding up the column into the base itself. What I decided to do was, in terms of welding the pedestal base and the tube together, is weld on the inside where the seam comes together. It's a nice tight seam there. I removed all the paint, cleaned it well. Now I'll go ahead and start tacking it in place. Okay, I got all the welding done. I tacked it in place about 6 or 8 times, and I went in and filled in between the gaps of the tacks with weld all the way around. I'll snug up those pinch bolts and leave them in place, but the primary strength is going to come from the welds. Well, now we got the pedestal or the base finished. We're going to figure out how we're going to mount the grinder on it. You can see I've just got the grinder just resting here. It's not bolted down yet. I put the two wheels, wire wheels I'm going to use on this grinder. They're not on, they're tight. They're just sitting on the wheel, on the spindles. Since I'm right-handed and I predominantly use brass for my wire wheel work, I think I'm going to put the brass on the right. And this is a fine steel wire wheel. Put that on the left. I can of course change those around later, but I think being right-handed, that'll work best for me. This wire wheel I picked up at a local big box store is a little bit on the fine side. It's actually even finer than the brass. So I might end up changing it out to go a little coarser wheel. I don't use a lot of steel wheels. I use mostly brass. You notice I've got the grinder with a little bias towards the front. Here you can see I still want it centered over the stand, but I want it pulled forward just a little bit to make it a little easier for me to get at and for clearance here when I get the rest of the hardware and attachments on the grinder. The grinder is not quite finished yet in terms of attaching. There's the rest, there's some guards that go, clamshells that go on both sides, something like this. I'll put those on once I've got the grinder bolted down to the stand. It makes it just a little easier and lighter to handle right now the way it is. Let's move around to the back side. I temporarily have just a zip tie holding the cord up and out of the way so it's not dangling around on the floor. In terms of the mounting holes, there's really two. There's one over on the right and one here on the left in the base of the grinder. This one on the right actually lines up with a slot in the pad already of the pedestal. The one on the left side there, I'm going to have to drill and cut a slot, probably a slot. I'll drill it first, then maybe slot it. We'll see. But I think that's about where I'm going to position it. Of course, it can be changed later. There's really nothing terribly sacred about that positioning. That's where I think I'm going to start. So we'll go ahead now, see about getting the stand, or getting this grinder mounted to the stand. A couple of things I wanted to point out before I go ahead and finish putting this grinder back together, mounting the wire brushes, the wheels, is the shaft is designed for a Woodruff key, as you can see here where I'm pointing to. And my left hand is one of the original keys, or the original key that came out of it. And it looks like it was probably homemade. The other side didn't have a key in it, believe it or not. So I had to fabricate two new keys of my own simply because I didn't have this size available. I did have some key stock, so I just made one up on a grinder real quick. Took about 20 minutes or so to make a new key. The other thing I wanted to share is that inside of this depression here I'm pointing to, originally there was felts. This is one of the original felts, and again there was only one felt on this machine. The other side, the second side, didn't have one. And I believe those felts are just designed to keep the seal, there's a seal inside of here, clean and keep debris out of the seal. About a 1/4 inch thick. What I ended up doing is just taking a piece of felt. Actually, this was a pad, chair pad. It just happened to be the exact diameter. This is 1.5 inches. So I had some chair pads that we use in the furniture in the house, a package of them left over from a previous project in the house, and I made my own felt, 2 of them, of course, and it just had to cut out the inside diameter there that will fit over the shaft. Actually, what happens, this felt will go something like this, and then this plate slides over the shaft and over the keyway. You can see where that's keyed right there. So now we're going to go ahead and finish putting the wire wheels on it, and then we'll do a little final review of the project and consider this done. Well, this is the final review of the 8-inch Black & Decker vintage bench grinder, pedestal grinder that I picked up several months ago at a local flea market. It's about done. You can see I got it mounted on a pedestal. And a couple of things I want to talk about here as we bring this project discussion to a close. My intention all along was to use this machine with wire wheels. So I have a soft brass on the right. I put it on the right because I'm right-handed, and that will be predominantly the one I'll be using, the brass. I do have a soft steel brush over here on the left. That might be a little bit too soft, frankly, and it might be a little bit, as you see it mounted on a wheel there. Move this over a bit for you. It might be a little bit too far to the right, so I might have to shim that wheel over. You can see it's already starting to take a little bit of the paint off right there on the lower right. The hardware used to put this back together, that being the nuts and bolts attaching the various pieces together, are mostly original. There are a couple pieces I had to replace because there was some mismatch of hardware that had occurred over the years. So, but most of it is original, such as these bolts that hold the tool rests on, the bell covers on, etc. And then, of course, I cleaned them up, de-rusted them, degreased them, and repainted them. The switch is original there at the bottom, or at least it was original in terms of it was on this machine when I got it. I don't know if it's original to the machine itself. I suspect it probably is, but it works fine. You'll notice over here on this side, move over a little bit, right there, that I mounted a pair of safety glasses. Never, ever, ever allow me to repeat, ever use a wire wheel without eye protection, because these wires do fly off, and you will be very sorry if that happens and you don't have eye protection. So both my bench grinders have a pair of safety glasses conveniently mounted, and I do wear them religiously when I'm using these wheels. Even though I wear street glasses, I put them right over the top of my daily glasses that I wear. You'll notice also here on the pedestal, the water reservoir, that's what that is. I've just got it turned 180 degrees. I won't typically be using that with a wire wheel much, because I don't overheat things especially when you're using brass. But I did want to keep it with the pedestal in case I ever do put grinding stones back on it. All I got to do is loosen that bolt right there, spin it 180 degrees, put water in it, and I'm back in business. The mounting bolts used to attach it to the grinder to the pedestal itself are new. I did not paint those, and just in case I had to move this unit back and forth and finesse the adjustment, so I didn't paint those. I use lock nuts to secure it. Not necessary to use lock nuts or nylock lock nuts, I should say. I use them because I had them in my inventory. If I had to go out and buy them, I probably wouldn't have used nylock nuts. I would likely have just used regular nuts with Loctite or similar thread locker. Those are, I believe, if I recall, 3/8 by 2 bolts. Just by way of reminder, these are the original grinding wheels I took off of that unit right there. Again, someone got their money's worth out of those, and they will be scrapped or tossed away. Obviously, they're no use anymore. In fact, they're probably unsafe. I think one of them has cracks in it somewhere. Who knows how old these are? These could easily be 60 years old. The grinder is probably close to 80 years old right now, as far as I can tell. I think it was built sometime in the mid to late 1930s. smooth as can be. It runs really good. So I'm looking forward to using this. And the only other challenge now I'm presented with is where I have my grinder, this grinder, to the left is my drill press. Behind that is one of my two lathes. The other lathe is all in pieces in my pole barn. I've got to figure out what I'm going to do about electrical. So well, the problem is that my electrical is all along the walls, and the only electrical in the ceiling or in the middle of the room is for the garage door openers, because I have two garage doors in this shop. What I'm thinking I'm going to have to do is probably pull a new 20 amp circuit from my panel. There's plenty of room in the panel for expansion. Pull a new 20 amp line over from the panel through the ceiling. I do have access to the ceiling. I have a stairway that goes up into the ceiling. And put a drop over this equipment space right here, at least one, if not two drops, so that I could plug everything in easily without using extension cords. Right now I have to use heavy extension cords, which is, besides being a trip hazard, is just inconvenient. So that's another project for another time, another place. Maybe yet this fall when it gets a little bit cooler and it's not quite so hot up in the attic, I can spend a day up there fishing a new 20 amp line, 12 gauge wire. Might even go to 30, we'll see. I got, again, plenty of room in capacity in my panel for that. That's it for this discussion and process review on the little, well, it's not so little, probably weighs 75 to 100 pounds. Black & Decker vintage 8-inch grinder. I hope you found this interesting. Any questions, issues, or anything else you'd like to talk about, feel free to drop me a note below in comments. Otherwise, thanks for watching.